Hello everyone, thanks for having us. My name is Frederic and I'll be presenting our work on spatially distributed robot sound. Spatial sound is used in films, interactive media, and many other audio-related domains to immerse, guide, and affect the listener. However, it has so far received little attention in the field of human-robot interaction. We believe that should change. We are seeing more and more electronic, audio-capable devices in our homes be connected, and this connectivity can be used to create spatial sound environments. This figure here is taken from a recent patent by LG, for example. As a result, we can expect that at some point we will have spatial audio in a large number of homes. So we wondered, how might human-robot interaction benefit from this technological affordance? Specifically, we asked, how does a robot with the ability to selectively emit sound across its body and the surrounding environment affect a human's impressions and behavior? To tackle this question, we pursued a research through design approach, creating two rich and comprehensive robot sound designs, having participants experience these designs and then learning about their impressions through semi-structured interviews. The robot that we designed for was Diamandini, a 1.5 meter tall robotic artwork that was created in 2013 by the third author Mari Velonaki. And we deployed this robot in the National Facility for Human-Robot Interaction Research. We had loudspeakers integrated into the robot and distributed across the space, meaning that the robot's sound could be emitted either from its body or across the environment, or both. The audio system making this possible consisted of a wireless local audio server inside the robot, which would address speakers enclosed inside, and an audio server for the room system, which addressed speakers across the space. Soundscapes and audio events would then be remotely triggered through a tablet interface. We created two designs, one we call Marble and the other one we call Cloud, both of which were derived from previous work we had done. The Marble design was emitted exclusively from the robot. Its underlying metaphor was that of an animate stone sculpture, and all sound it emitted was derived from a common source material, which was stone. The Cloud design was emitted from the robot and across the environment. Its underlying metaphor was that of a bodiless digital entity, which can move freely across the environment or be embodied within a physical robot structure. Its sound material was oriented towards conventions of user interaction sound, which is common in various types of mobile and smart devices. In other words, the robot had a mind and a body, and the mind could inhabit the body, but it could also be distributed across the entire space or float to a specific location that may be relevant to the interaction. A helpful example is to imagine that you want to interact with your robot upstairs, but the physical robot cannot get upstairs. So instead, the embodied robot turns into a disembodied virtual agent that can go wherever there are loudspeakers. Here is a video clip that showcases the two sound designs. These designs we then showed to participants, giving them around 10 minutes to interact with each before we would move on to the interviews. 5 themes emerged from our conversations regarding the effect of spatial robot sound on participant attention and behavior, the experiential qualities of the immersive audio experience, the effect of spatial sound on perceived robot animacy and agency, the characteristics conveyed by the sound content, and participant impressions on musical presence and movement sound. I will expand on the first 3 themes in particular. Attention and behavior. Most participants reported that sound elements in the environment directed their attention away from the robot, while local sound placed the robot at the center of attention. Referring to the spatial cloud design, one participant said, "It very much took my attention away from the robot. I was more focused on the sound itself and on figuring out where it was coming from." Using sound to draw attention to and away from the robot had implications for how and whether participants interacted with it at all. Essentially, muting the robot made participants perceive it more as a peripheral bystander than a social agent to interact with. Speaking of the spatial design, one participant said, "I don't have to engage with her if I don't want to." Experiential qualities. Participants made various comments which did not focus on the robot or their interaction with it, but more generally referred to the experience of being enveloped by sound. Regardless of whether they considered the existence of spatial sound useful, necessary, or appropriate, they found it interesting, engaging, and novel. One participant said, "I really enjoyed that experience. It was a really cool interaction because it's something that was new. It was moving through the space. That's something I don't really experience very often." Another one said it was more poetic and dramatic in a way. It all sort of flowed nicely. I was quite happy to just experience that, and maybe my interaction did something, maybe it did not, but it did not bother me. Animacy and agency. Participants attributed different degrees of animacy and agency to the robot based on whether it locally emitted sound or not. Specifically, they described a robot that emitted sound locally as more animate and more in control. One participant said, "When the sound is kept to Diamandini, embodied within her, in a way she becomes a bit more alive." Another one said, "When no sound is coming out of the robot, you don't see that agency or these human attributes. You see that it's part of another system. The robot is just another accessory of the system." Participants' opinions on what they preferred were quite diverse. Some wanted a more animate, self-contained robot, while others did not. One participant perceived the marble design as very disquieting and considered it much more natural to think of the robot as being externally controlled rather than something that is alert on its own. When considering these findings, some limitations should be noted. First, we did not present participants with a specific use case. So while our findings demonstrate the potential of spatial sound, further work is needed to identify the applications where it is appropriate or where it is not. Second, our designs did not contain speech. So it's an open question whether the addition of speech content changes how much nonverbal robot sound can affect attention. It could be that once a robot begins to emit speech, other nonverbal sound is classified much closer to background noise, which could then reduce its impact. To summarize, we found that the spatial distribution of robot sound had several notable and intriguing effects, including how much attention participants paid to the physical robot compared to the environment, whether they considered the robot's intentions and actions as something irrelevant that could safely be ignored, whether they considered the robot as a self-contained agent with its own decision-making process, or as an accessory to a broader ambient intelligence, and how novel and engaging they considered the experience as a whole. For designers, this suggests that the spatial distribution of robot sound may be a powerful new tool to engage users and to dynamically and implicitly direct their attention and expectations during HRI scenarios. And this brings me to the end of the presentation. Thank you very much for your attention.